Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss mechanism of micelle formation. Last class I have discussed classification of colloids. Now before going to mechanism of micelle formation, again I want to repeat micelle. Micelle means associated colloids. There are some substances which at low concentration behave as normal strong electrolytes, but at higher concentration exhibit colloidal behavior due to the higher concentration. Due to higher concentration exhibit colloidal behavior. Okay, this you remember. Due to formation of aggregate. The aggregated particles thus formed are called micelle. Again you listen. There are some substances which at low concentrations behave as normal strong electrolytes at low concentration, but at higher concentration exhibit colloidal behavior due to the higher concentration. Okay, or this happens due to the formation of aggregates. Means at low concentration behave as a normal strong electrolyte, but at higher concentration exhibit colloidal behavior due to the formation of aggregates. The aggregated particles thus formed are called micelle. Aggregated particles thus formed are called micelle. These are also known as associated colloids. The formation of micelles takes place only above a particular temperature called Kraft temperature. Kraft temperature means Tk, capital T and K, down K. Kraft temperature, and above a particular concentration called critical micelle concentration. In short, CMC, capital C, capital M, capital C, CMC, critical micelle concentration. On dilution, these colloids revert back to individual ions. Surface active agents such as soaps and synthetic detergents belong to this class. Okay, surface active agents such as soap and synthetic detergent belongs to this class. For soap, the CMC is 10 to the power minus 4 to 10 to the power minus 3 mole per liter. This is the concentration, critical micelle concentration. Okay, for the soap, that is a 10 to the power minus 4, 10 to the power minus 4 to 10 to the power minus 3 mole per liter. These colloids have both hydrophobic and hypophilic parts. These colloids means soaps, example soaps, have both lyophobic and lyophilic parts, both lyophilic and lyophobic parts. Micelles may contain as many as 100 micelles or more. Now I am coming for the mechanism of micelle formation, how micelle is formed. Okay, in a simple way, you should remember associated colloids, okay, associated molecules in a larger quantity, that you remember. Whenever micelles word came, you think associated colloids, associated molecules, okay, in large quantity. Then now I am telling about mechanism of micelle formation. It is easy to understand. Okay, just take the example of soap solution. Soap. Then what is the soap? Soap is a sodium or potassium salt of a higher fatty acid. What is the soap? Then soap is a sodium or potassium salt of higher fatty acid and may be represented as RCOO Na plus or RCOO K plus. Okay, in sodium salt or potassium salt of higher fatty acid. Here R may be long chain hydrocarbon. Okay, particular example of soap I am telling you. Sodium stearate, stearate, sodium stearate means CH3 CH2 whole 16, means total 17 carbon. In hydrocarbon total 17, CH3 CH2 whole 16, then 16 carbon is with CH2, 16 CH2 plus CH3 means total 17, and after that COO Na plus, then COOH is carboxylic acid, then in the place of H now it is sodium ion. Then now this is called sodium stearate, CH3 CH2 whole 16, COO Na plus, then COO that is minus charge and Na is plus charge. Then here CH3 CH2 whole 16 COO 1 minus, this is called stearate ion. Okay, it is called stearate ion, COO minus, because in water it will dissociate in stearate ion and sodium ion. Then CH3 CH2 whole 16 COO 1 minus is called stearate ion. Okay, which is a here this stearate ion is a major component of many bar soaps. Okay, in soaps actually there are two types of soaps, bathing soap and this one is for cleaning purpose, correct? That is called washing, WASH, washing. Then sodium, if sodium salt is there, then it is called washing. And for bathing, BATH, for bathing, if potassium salt is there, then it is called bathing soap. Okay, then whenever sodium salt is present, then it is called washing, WASH, for the cleaning purpose, cloth cleaning. But for bathing, potassium salt will be there, potassium will be present, then it's called bathing soap. This is also called soft soap, and washing, that is called hard soap. Okay, then now this I told you about the soap. When dissolved in water, it dissociates, particularly I am talking about this bar soaps means washing soap, detergent soap I am talking about. When dissolved in water, it dissociates into RCOO 1 minus plus Na plus. Okay, it dissociates into RCOO minus and Na plus ions. The RCOO ions, however, consist of two parts. RCOO, that is, as for example, stearate ion. R means here CH3 CH2 whole 16. That is the R, and COO minus is there attached. Hence, it has a two part. RCOO 1 minus ions, however, consist of two parts. A long hydrocarbon chain. A long hydrocarbon chain are also called non-polar tail, because it is a long non-polar tail, and other part, actually this non-polar tail means long part is a hydrophobic means it hates the water, it repel the water. Okay, water you can say water repelling, and polar group, that is the COO minus, COO 1 minus, that is the polar group. Then in this RCOO, two parts is there. One is lyophobic or hydrophobic, you can tell, and other is hydrophilic. Okay, means water loving. Then if you will expand it, then you can write in the beginning it will be CH3. After that bond you write CH2, again one bond CH2, again one bond CH2. Like that way you can write CH3 down, CH2 up, again you bring down CH2, again up, again down, again up, again down. Like that way you can write CH3 only in the down, you can write a starting. After that only always CH2, one CH2 up, other CH2 down, again up, again down, again up, again down. Every time CH2 only will be up and down. Okay, then at the end it will be COO group. Okay, and the end it will be COO group, COO 1 minus. Then CO, one oxygen is double bond, C double bond, CO, and other oxygen is single bonds. Both are joined by carbon only, C double O. Okay, C double bond O, and one oxygen is joined by single bond, and oxygen which is a single bond, they have negative charge, 1 minus. Okay, then long chain, it looks like a long chain. Then here long chain of hydrocarbon is called tail, 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 because it is long, just like a tail. And this COO minus, that is called head, head and tail, because it is the end. COO is in the end. Okay, it is a head, and back is tail. Back is hydrocarbon, that is the tail. Then in this RCOO minus, R represent tail because it is long chain, and COO, which is a negative part, that is called head. Okay, then you know that this tail, that is the hydrophobic, means it repels the water. water header, and this COO minus, that is the water loving, water attracting. Okay, then this I have told about the this structure, that is the I talked about the RCOO. Then this is actually important things I have discussed. Now suppose you have put soap in water, then what will happen? That sodium will go in the water, it will dissociate sodium ion, it will dissociate in the form of sodium ion plus stearate ion. Then this stearate ion has two parts. Then this negative part means COO, that will go towards water because it is water loving, and this hydrocarbon part which is water heading, it will go up, it will not try to go inside water, it will keep ahead, it will project like that, that tail will be upside, it will not go to the water. Okay, only head will be towards water, tail will be not in the water, this you remember. Okay, then it will form arrangement, you will see arrangement of stearate ion on the surface of water at low concentration of soap. Now you have to think concentration. If concentration of soap is low means low concentration, then this will be, tail will be upside, stearate and tail will be upside, and COO, that is the head, will be into the water or in water. Okay, and when you can say this soap has low concentration, but now in the micelle more concentration is required, then suppose arrangement this same now we will see arrangement of stearate ions inside the bulk of water. Now if soap is more, then what will happen? It will form ionic micelle, because concentration of soap is more, then it will form micelle, that is called ionic micelle at critical micelle concentration of soap. Because now second case, first case tail is upside, but now if soap concentration is more, then what will happen? That tail will go down and outside towards water. This outside will be COO, means towards water side, and tail will be in middle, tail will be in the, you can say, bulk. Okay, inside the bulk. Then always you can suggest to think that always tail will keep in such a way that there will be no water. Okay, they will arrange in such a way that tail means hydrocarbon chain, that will be not in the water direction, not in the water, always it will be far from water, away from water. Okay, then this I have told about the formation. The RCOO ions means stearate ions are therefore present on the surface with their COO groups in water, and hydrocarbon chains are staying away from it and remain at the surface. Upside it will there, or anyhow it will be far from water. but at means this I told, when soap concentration is less, then it will be far. It is staying away from it and remains at the surface, means upper surface. But at critical micelle concentration, means more concentration, the anions are pulled into the bulk. Here important things. But at critical micelle concentration, means high concentration, the anions are pulled into the bulk of solution and aggregate to form a spherical shape. That time, if concentration is more, means micelle concentration, then striate ion, the striate ions, means anions, are pulled into the bulk of the solution and aggregate to form a special shape with their hydrocarbon chains pointing towards the center. Okay, when CMC at higher concentration, that it will form a spherical shape. In that shape, a spherical shape, with their hydrocarbons chain pointing towards the center of the sphere, with COO part remaining outward, just like on a what you can say, just like a sphere, then upper portion of a sphere, COO part will be there, and in the center this hydrocarbon will be there, means tail will be there. Okay, then they will aggregate, but situation will be like that. They will aggregate to form a spherical shape with their hydrocarbon chains pointing towards the center of the sphere, with COO part remaining upward on the surface of the sphere. Okay, an aggregate thus formed is known as ionic micelle. Then this sphere is called, this sphere in which COO is upper part and hydrocarbon is in the center, then this sphere is called ionic micelle. An aggregate thus formed is known as ionic micelle. These micelles may contain as many as 100 such ions. Okay, these micelle forms, then these micelles may contain as many as 100 such ions, means striate ion, 100 striate ion it can contain. One ion means striate ion I am talking about, like this striate ion, hundreds may be there, 100 striate or more than that may be there. Okay, similarly in case of detergent, this I told about the soap. Now come to the detergent. Then this will be, there is all similarity will be there, same type of behavior will be there, micelle formation behavior will be the same. Similarly in case of detergents, that is the sodium lauryl sulfate, LAURYL, lauryl sulfate, that is the CH3 CH2 11. Now CH2 is only 11, but in soap, in stearate it was 16. In stearate it was 16, CH3 CH2 whole 16. But here CH3 is there, CH2 is also there, but number is only 11. Okay, but there it was COO minus. In soap COO minus was there, but here sulfate is there, sulfate SO4Na. There also Na was there, here also Na is there, but there it was the COONA, correct? Stearate ion, sodium stearate, COONA plus was there, but here CH3 CH2 whole 11, SO4, you know that it is the minus SO4, then there Na will come, Na, because SO4 has 2 minus, then 1 minus is associated with hydrocarbon, and only one SO4 is remaining 1 minus, that is associated with sodium. This is the example of detergent. And soap and detergent difference I told you. There it is a carboxylate ion, COO minus. Here it is the sulfate. And in acetate 16 CH2 was there, 1 CH3 was there, after that 16 CH2. Here also CH3 is there, but 11 CH2 is there. This is called detergent. And here the polar group is sulfate ion, SO4 2 minus, or SO4 1 SO4 1 2 charges there negative, but one charge is involved with making bond with hydrocarbon, and other one ion is with sodium. Then here an ion you can tell SO4 1 minus plus Na plus. Then this I told you that the polar group is here. Polar group is SO4 1 minus along with long hydrocarbon chain. Hence the mechanism of Micelle formation here also is same as that of soap. Now I am telling about this cleansing action of soap. Cleansing action of soap. How it will clean? Here our cloth, particularly in collar side, in shirt or any surface, or in the surface of any cloth. Suppose dirty is there, then actually that particularly I am talking about the on collar, there will be more, you can say, dirty, more collection will be there for dust in comparison to the other parts. Other parts easily it will dissolve in water, but on collar dust will be strongly held. Okay, it will not dissolve so easily. Actually that is called oil, or grease. Okay, that dust near the collar particularly, that is called oil drop or grease like situation will be there. Character will be of like a grease or oil drop. It is called oil drop. Actually these are the charged particle. Then here how soap cleans it, what is its action, that I am telling you. Okay, here what will happen, that you listen, it is very conceptual, that it has been already we have discussed about the soap. Already we have mentioned earlier that a micelle consists of a hydrophobic hydrocarbon like a central core hydrocarbon, hydrophobic hydrocarbon like central core. The cleansing action of soap is due to the fact that soap molecules form micelle. Soap molecules form micelle because more soap you will use, more soap, hence it will form soap micelles. Okay, this cleaning action of soap is due to the fact that soap molecules form micelle around the oil dropped, okay, in such a way that hydrophobic part of the stearate ion is inside the oil droplet or is in the oil droplet, and hydrophilic part projects out of the grease droplet or oil droplet, like the bristles like the bristles. Since actually a sphere form, it will form in the spherical form. Then spherical form means outside will be polar. Polar means water loving, and inside of wild droplet hydrocarbon will be there, just like near the center. Near the center hydrocarbon will be there, and near the center of a droplet, wild droplet or grease droplet, inside it will enter, correct, and outside what will be there? Outside negative part will be there. Negative part means that COO minus, okay, polar charge will be outside and hydrocarbon side will be inside of this droplet, grease droplet. Okay, since the polar groups can interact with water, the wild droplet surrounded surrounded by straight ions. Straight ions is now pulled in water and removed from the dirty surface. Correct? Like that way it is cleaned. Again I am telling you, since the polar groups can interact with water, the wild droplet surrounded by a straight ion is now pulled in water. It will come, means dirty things or grease droplet will come in water, because that outside polar charge is water loving, hence it will be attracted towards water. Okay, and then this straight ion will bring that droplet, grease droplet or wild droplet will come with this ion, straight ion, correct, because one part is inside of the dirty you can tell, while or grease one side, and upper side is polar, and that is water loving, hence more water is required, because they will that oil or grease will be just come with water, because our part is water loving. Okay, hydrophilic, that's why this complete ion will come out with water. Okay, and this while and droplet is attached with now a stearate ion. Okay, it is because inside it is long chain inside core, and outside is this water loving. Okay, water loving, hydrophilic. That's why if you will wash it with more water, then all you can say this oil or grease particles droplet will come out, leaving the surface of cloth. Okay, this is actually mechanism. This is the cleansing action. This I have discussed. Okay, since the polar groups can interact with water, the wild droplets surrounded by droplet surrounded by stearate ions is now pulled in water and removed from the dirty surface. Thus, soap helps in emulsification and washing away of oils and fats. Okay. The negatively charged sheath. Now other things I am telling you. Negatively charged sheath around the globules prevents them from coming together and forming aggregate. that again they should not come back. For that purpose, what happens? The negatively charged sheath around the globules prevents them from coming together and forming aggregates. Now I am going to tell about preparation of colloids, how colloids is formed. Actually, now you are knowing about the micelle formation. Micelle formation, what is the micelle? All things you are knowing, that is simply collection or aggregate that you remember. Association of molecules or ions. If less ions, then no micelle formation. If more concentration of soaps or detergent, only then micelle will be formed. Okay, micelle formation is only at CMC or temperature. I told you above certain temperature, that is called Kraft temperature. Both things always consider. Then now here you have to study about the colloids. Now general information I told you, but now how it is prepared, means preparation you have to study. After the preparation, what is properties, that properties you have to study, correct? And then after the properties, you have to study purification, how it is purified, okay? And after that, in nature, where it is used or where it is available, that you have to study. Then it will be the, you can say, full study of colloids. And now I am going to discuss this preparation of colloids. Just like other preparation, many metals are there, many compounds you are preparing, then many methods are there to prepare the compounds. Like that way, here many methods are there to prepare colloids. Then preparation of colloids means that you have to create such type of situation that many ions will be produced, and these ions will be in more concentration and can associate. It can associate. Then that association will be called sol, S-O-L, sol. But this will be in a particular solvent. As for example, water. That ions must be present in water. If it is hydrosol, okay. Otherwise, in general, other solvent also may be there. Then you know that these particles are called dispersed phase, and solvent is called dispersion medium. Phase and medium, dispersed phase and dispersion medium. Then in all preparation, you will see that your intention is to make or to get ions in more concentration, in more number, and it should be present in the suitable dispersion medium. Then now I am telling some methods I am telling you. First, chemical methods. Then here what will happen? Colloidal solutions can be prepared by chemical reaction leading to formation of molecules by double decomposition. First method is double decomposition. Second method is oxidation reduction. Or third, you can say hydrolysis. These three methods are common. These molecules then aggregate. First you will form molecules, and these molecules then aggregate, leading to formation of salts. Example, I am telling you that arsenic oxide AS2O3 plus hydrogen sulfide H2S if both will react, AS2O3 plus H2S. If you want to write in a balanced form, then AS2O3 plus 3H2S. Then double decomposition will take place, means AS2O3 will decompose and H2S will also decompose, and it will form sulfide, arsenic sulfide it will form. AS2S3 it will form plus H2O. Okay, it will give two product, AS2S3 plus 3H2O. Then AS2O3, that is actually sol. This is the sol. Okay, this one example I told you, sol. Okay, colloidal sol of AS2S3 arsenic sulfide. Second example, SO2 plus 2H2S hydrogen sulfide, again hydrogen sulfide, SO2 plus 2H2S. Then now it will form 3S sol plus 2H2O. Okay, 3S because SO2 plus 2H2S. With 2H2S, 2S is there, one is this SO2. Then 3S in the form of sol you will get plus 2H2O. Then here sol you are telling, because now these molecules, first case arsenic sulfide, second case sulfur, their size is in the range of 1 nanometer to 100 nanometer. Within 1 to 100 nanometer size is there, and they are aggregating. Okay, keep in mind. Then that's why it is called sol. Okay, after aggregation their size is between 1 to 100 nanometer. Now third example I am telling you, auric chloride, AuCl3 plus formaldehyde plus water. Three reactants are there. Two balanced equation I am telling you, 2 AuCl3 plus 3 HCHO plus 3 H2O. Then it will give three product. Three reactants will give three product. Then what are that things? Then actually this is the example of hydrolysis. First example, what I told, double decomposition was there. First example, AS2O3 plus 3H2S. Okay, double decomposition. Second example, SO2 plus 2H2S, that was the oxidation. And now I am telling you 2 AuCl3 plus 3 HCHO means formaldehyde plus 3H2O. This is the example of hydrolysis, and it is giving three product. Then first product is 2Au sol. This is the main. 2Au sol plus formic acid means 3HCOOH plus 6HCl. Then out of this three, only auric is in between 1 nanometer to 100 nanometer, not other two. That's why this Au auric 2Au, you got 2Au plus 3 formic acid means 3HCOOH plus 6HCl. Then here 2Au sol you got, because it's after the aggregation of auric gold, its size is between 1 to 100 nanometer. Size is important here. Then this I told you chemical methods. Three examples, fourth examples also I will tell you. Three already told you. Fourth example here, that is also hydrolysis. FeCl3 plus 3H2O. FeCl3 plus 3H2O. This is also hydrolysis. It will give two product. FeOH whole 3 ferric hydroxide. It will give a ferric hydroxide ApCl3 plus 3H2O. 3H2O is there. Then it gives ApOH whole 3 plus 3HCl. Then here ApOH whole 3, this is the sol, colloidal sol, because again ApOH aggregation of many ApOH just aggregated, associated and form colloidal sol of the size means this ApOH whole 3 after association it is forming size between 1 to 100 nanometer. Now this I told chemical method. Now I want to tell you electrical disintegration. Electrical disintegration are also called Bredik's arc method. Bredik's arc, Bredik's, Bredik's arc method, also called electrical disintegration. This process involves dispersion as well as condensation. Okay, here both process will be present, that is the dispersion as well as condensation. Okay, now here I told you that you will use electrodes, arc you will make. Okay, by this method what will happen, arc also called Bredik's arc method. Here in this method electric arc is struck between electrodes of metal immersed in the dispersion medium. Means you have taken the dispersion medium, in that two electrodes you have taken, dipped. Two electrodes you have dipped and you have passed the current. Okay, then both electrodes are made up of metal, and one electrode will function as cathode, other will function as a anode. Means electrodes is dipped in the medium, dispersion medium. Okay, and through the electrodes you are passing the current. Then here what will happen, the intense heat produced, because you are passing the current through the electrodes, and an electrode is present in the water. Okay, means water means here dispersion medium, any suitable dispersion medium. The intense heat produced vaporizes the metal. Purpose is that you are passing the current because metal should vaporize. Metal molecule should dissolve in medium, dispersion medium. The intense heat produced vaporizes the metals, which then condenses to form particles of colloidal size. Okay, this intense heat produced vaporizes the metal, which then condense metal, which vaporizes in the form of maybe ion, maybe molecule, whatever be. Then after that it will condense in you can say dispersion medium. Okay, vaporizes this heat produced vaporizes the metal, which then condenses to form particles of colloidal size. Okay, this I have told you. Now next method I am telling you, that is the peptidation. Very, very important for examination. Peptidation for every examination, even in general competition also it is asked. Then third method is peptidation. Then peptidation may be defined. What is the peptidation? That try to understand. Peptidation may be defined as the process of converting a precipitate into colloidal sol by shaking it with dispersion medium in the presence of a small amount of electrolyte. The electrolyte used for this purpose is called peptizing agent. Means here you require, what is this process? I told you that it is defined as the process of converting a precipitate into colloidal salt, but with the help of a small quantity of electrolyte. After mixing electrolyte, you have to shake it. Then colloidal particles, now you want to convert this, not colloidal, precipitate you want to convert into colloidal particles. Okay. The here main thing is that precipitates you want to convert in colloidal particles. Means size of the particles should be in the range of 1 to 100 nanometer. Okay. Then here precipitate you are converting into colloidal particles with the help of suitable, you can say, electrolyte in a small quantity. This electrolyte in a small quantity you will dissolve and you have to shake it. Then what will happen? This precipitate will convert into the colloidal particles. Means size will come under 1 to 100 nanometer. Okay, colloidal size. And this actually electrolyte is called peptizing agent. Okay. This method is applied generally to convert a freshly prepared precipitate into a colloidal salt. During peptization, the precipitate adsorbs. What happens actually, that now you listen. During peptization, precipitate will adsorb one of the ions of the electrolyte on the surface. Means precipitate will adsorb ions, okay, on its surface. And this ion, what it will do? Due to the presence of these ions, this causes the, means adsorption causes the development of positive or negative charges on precipitates. Either it will create positive charge or negative charge. Means this ions causes the development of positive or negative charge on precipitate, which ultimately break up into a smaller particles of the size of a colloid. Particles, precipitate are the bigger size. Now you want to break it a smaller size. Then these ions, when electrolytes ion will go there, any one ion, then what will happen? They will break it, because dispersion, this will be there, repulsion will be there. If suppose same type of ions are there, now they absorbed either negative, suppose a negative charge adsorbed there, then a negative, what will happen? Repulsion will be there, then it will break into many parts. Okay, it will break the precipitate into a smaller parts. Or if positive is there, everywhere positive, then again repulsion will be there, then it can break, and now particles will precipitate will convert into the a smaller particles of colloidal size. Okay. Then now I have discussed these things, preparation. Now I will discuss purification of colloidal solution and properties. Both I will discuss in the next class. Thank you.